Desk of LADYADA.
Hey everybody, and welcome to yet another Sunday night Desk of LADYADA. We're trying to get these back onto somewhat weekly schedule. We're going to keep trying to do them Sunday night. It's me, LADYADA. This is my desk. With me is Mr. LADYADA's on camera control, the voice in the background.
If it's Sunday around 8, there might be LADYADA.
All right.
Okay,
well, here's what we're going to do today. We're going to show off this sensor from AMS, the AS7341 11-channel spectral sensor. We have a breakout that we made. So I'm going to do a little demo showing it off. And then I'm going to show how you can search on Digi-Key for high CRI white LEDs. Now, one of the things that's always a challenge is every time you need a white LED in an application, there's like different specifications you need. And this is a specific kind of case. You want a high color index LED. So we'll show the process of me speccing out that part, and so you'll get a feeling of how to find LEDs when you're searching on Digi-Key. So you want to jump right into it?
Yeah, this is part of the great search stuff we're doing too. It says Digi-Key has a great search, and one of the things that we're doing is showing how to find stuff.
Great.
So this is part of Desk of LADYADA, because we do that usually every week.
That's right.
All right,
let's go to my computer. Okay, so you can go to digikey.com and look for AS7341. This is an interesting I2C sensor that has a grid of 12 channels, 11 channels, 11 different LED diodes inside of different spectral responses. And so you can get a pretty cool like spectroscopy machine type sensing, but in a little I2C LED sensor. It's not too expensive. It's, $5 or so, $6 a piece. It's not too large either. It's small. It's easy to pick in place. I actually even hand soldered them. So we have a library that we're working on in Arduino and CircuitPython. So let's take a look at a demo. Hopefully this is still working. Okay, so this is the Arduino plotter, and let's also show the overhead so people can see what I've got here. So this is the sensor, the AS7341, and you can see it's soldered here in the center with two stemma QT quick connectors, and I've got it hooked up to a Metro Mini. So it's an Arduino Uno compatible board basically. It's reading, right now it's only reading 5 channels because having more than that actually got a little bit confusing on the plotter, so I'm going to stick to the 5, red, orange, green, blue, violet. Although it can do IR, and it can do a couple other oranges and greens in between. And then what I'm going to do is I'm going to stick LEDs into this breadboard, like this green LED, and then I'm going to point the sensor at it, and we'll see on, well, it really didn't like that.
that's fine.
Yeah, whatever. Anyways, we're going to go to the computer, and then people can guess what color LED I have. Okay, so this is the first LED. So what color do you think it is?
I'm gonna go with green.
That's a good guess.
Because you just had shown it.
Yeah.
So my first guess is gonna be green.
You can also see that the green line here, the green channel, is maximized, and there's a little bit of like orange, yellow, and purple, but it's mostly green.
The green line is also helpful.
Yeah. Okay. So
I'm glad there's a chart that I'm looking at that's not a COVID infection rate chart tonight. I'll get back to that later.
Okay. And you can see down here also, you can see there, these are the spectrum colors: red, orange, green, blue, purple. Okay. So then this time I've got a different color LED. This one is a red LED, but you'll also see a lot of orange in it. That's not uncommon. Most low-cost LEDs have a bit of a spectral spread. So the orange diode is also picking up some of it. If I back it off a little bit so that I'm not saturating the diode, you'll see that there is a lot more red than orange, but there's still quite a bit of orange and almost no green, blue, or purple.
What's the measurement? Is it kelvins? Like how is it?
This counts. Anytime you have a color sensor, it doesn't give you like the Pantone shade, it just gives you the counts, like how many
Like the count from Sesame Street?
Yeah, basically.
One red LED.
Basically. Okay.
Okay.
Oh, shoot. I gotta unplug the sensor. Hopefully I can bring it back to life. Okay. So let's do another LED. You ready?
Yeah.
Okay, so this one, I don't know if you can guess, but it's a blue LED.
I'm going to say blue.
You're going to say blue because you can see that the blue line is the highest, but you can still see there's a little bit of purple as well. And then I have an orange LED, a yellow LED, but I'll say it's quite dim, and so you have to have it like really close.
Okay,
so you can
see it's orange.
Yeah, so you can see there's a lot of orange and less red. So the red LED had a lot of red, a little orange. The orange LED has a lot of orange, a little red. And then finally, I have a white LED. And white LEDs are kind of interesting because they're actually blue LEDs with yellow phosphor. The gain is pretty high on this. So you can see it's kind of broad spectrum. You've got orange and green and red and blue.
There, right? Yeah.
They're all in there because this white LED is doing its best to approximate what we see as white color. Okay, so the cool thing about this sensor is, as you see, you can now detect LEDs. And that's because, there's photons striking the diodes inside the sensor. But this sensor also has another cool capability. So let's look at the data sheet. So this is you can see the sensor and how you wire it up. And then there's actually control for a flash LED, for a white LED. There's a white LED driver, and it can drive it at 40 or 100 milliamps. So it's quite it's a good LED driver. And the idea is that you'd connect a bright white LED to it, and then it would illuminate, it would bounce light off of the surface you're measuring, and you would be able to measure back the colors, the spectrum that you're seeing. So, like we actually saw this a couple years ago. There's a lot of Kickstarters and like other crowdfunding projects that were like, you would hold a color sensor up to like an apple, and it would be like, this is an apple, and it has 50 calories. Like, I don't know if you remember that, but they were using spectral sensors like this one.
Okay.
Yeah. Anyways, so if you look at the user guide, if you look at the user guide, they have the specification, because they don't really say in the data sheet what kind of LED, they just say like white LED. But they do have on the eval board this UG YJ VTC 2835, blah, blah, blah. So let's look this up. So, yeah, sorry, I already had that open. Okay, so when you look up that LED by UG LED, it's a 2x8 by 3.5 millimeter. It has 120 degree emission range. And what's interesting is that it has really high CRI. So it has a 98 CRI, which is quite high. And it also says here, I think it's a 6500K LED, and you can see that they're like, you want to have it be broad, like as flat as possible. You're not gonna get perfectly flat, but as flat as possible, because you don't want the LED to be bouncing only red photons and green photons, because then you wouldn't be able to detect the orange spectrum, because the way our eyes work is we only see red, green, blue. We actually have no way to see other colors. But this sensor does. And so what looks like pure white to us is like our eyes tricking us with the red, green, and blue cones to think like, oh, this is a broad spectrum white color. But actually, if you look at the actual spectrum itself, it has a lot of dips. So this one isn't too bad. You can see, between about 400 and 650 or so. It has, not too bad. So you're never going to get perfect, but this is, for like a low-cost LED, this is pretty good. So, high CRI lighting, you might have heard of this because you bought like LED bulbs, and it's the color rendering index. Again, you want it to be as flat as possible to get the most correct rendering index. Sort of like, this is common you see with food photography. If you photograph food under like fluorescent lights, it looks really bad. But if you photograph it under like really good CRI lighting, the food looks very appetizing because it looks the way we would see it in sunlight. So let's go, actually, I looked at this product, but let's go to Digi-Key and pretend like I didn't just pull up that product, and let's search for a high CRI white LED. So you can't actually type in high CRI because, like, what's high? That's a qualitative thing. So instead, let's search for a white LED. And again, there's a lot of different topics, but we're going to go with LED lighting white. And there's 34,000 items. Like, white LEDs are really common. They're used in like backlights, in ambient lighting, and indicator light. It's like we love white LEDs, and so you do have to do a little bit of searching to find the LED that you want when you're looking for white LEDs. So as usual, I immediately just only show the active and normally stocking items. And that actually cuts it down a lot to about like 4,700. Next up, I'm going to look for high CRI. So it's really nice, and this is the kind of thing that makes Digi-Key search really valuable, is that they actually went through every LED and entered in what the CRI is. And like on most sites, if you're searching, you're not going to get that. Like, you have to dig through each data sheet. So really nice is here, you've got the values that you can search for. So I'm going to say 90 to 95.
Yeah, we do other desktop LADYADAs with other electronic supplier companies. That might be like the OK search, the good search, but we're doing the great search.
Like the mediocre search?
Yeah, and that's actually one of the things that we've wanted to do for a while, is like, being an engineer just isn't designing circuit boards anymore. It's like, how can you use very, very powerful tools to find the exact things you're looking for? It's almost just as important as where you put the part is how you find the part.
That's right. You got to find the right part. Because if you find the right part, your life's golden. But if you can't find it, there's millions of items in the Digi-Key catalog. Like, you can call the apps engineer, but even they won't memorize every part.
Yeah, and just to be clear, we have no plans to do a show called the mediocre search. We're only going to focus on the great search.
Okay. Well, this is a great search so far. We're doing great.
Just to be clear.
All right. So next up, I want to do some more slicing of these products. So I'm going to only look for the cut tape version of whatever LED is available. Because again, if it's available on a tape and reel, you're going to get Digi-Reel and cut tape, and tape and reel all available. So it's like three entries per one product, but I don't care about the packaging yet, so I just say cut tape. So I'm down to 200, and then I want to have the size be 2835, which, remember, is the size that was in this data sheet. Yeah, 28 by 35. So let's see what we get, because then it's like you only have 4 left, so that's actually pretty good. I think, hold on. Oh, I wonder if it's not normally. It's here. One second. $35.28. Oh, there's $35.28 and $28.35. Okay, I'm going to search by dimensions, not by the supplier device package. So I'm going to try this. Yeah, interesting. Okay, so this is something that does happen sometimes. So you can either search by the size or dimension, or by the official package name. But it looks like, I was like, oh, I want a 2.8 by 3.5 millimeter part, so it's 2835. But if I look for like this LED, which I ended up getting, the package is, hold on, I lost it. It was this one. The package is 1411 to PLCC, like it means a 2-lead SMD connection. And it's actually just come up for me sometimes. So what companies call their packages can be like even though they should probably call this a 3528 package. They don't. They call it just a PLCC package. They don't specify the size. So I'm glad I showed you that because it's something that has tripped me up before. So if you want to be sure, go with the size dimension, because like SMD, they could categorize it as SMD, not as like the size of the SMD component. So let's apply this filter. All right, so we're doing great. Oh man, I did that again. Hold on. 2835, and then also 3.5 by 2.8, so both ways. Okay. Yeah, now they're all coming out.
So someone mentions that they're making their own high CRI photo video light, and they found that the Thrive series from Bridgelux is second best after UG LED, but much more affordable.
Yeah, I mean, CRI is a really common LED supplier. Like you see, there's a lot of them here. What's really nice about CRI is they really bin their LEDs very well. It's kind of what they're known for. Yeah. You're going to pay more for it, but basically every LED in the reel is going to be the same. So we have a lot of options now. What's up?
Now what?
Now what? So there's a couple of things. What I did is I then said, well, they specified in here that it's 6500K, so that's the next thing I did, and then only one LED popped up. So this is 2835 LED lighting, 120 degrees, just like the other one. It can handle 150 milliamps, which is good because 100 milliamp is the amount of current that you can source from this chip. It's 6500K. It's a cool white LED, and forward voltage about 3.1 volts. So this is actually a pretty good LED, and the price is good too. It's like basically 10 cents, which is a total bargain for white LEDs. If you don't care about the Kelvin temperature and you just want the highest CRI, there's a different family, also 10 cents from CRI, that only goes up to 4000K. So the question is, like, what's more important, high CRI or high Kelvin? I think, I would probably buy some of each and try them out and compare them, especially with actually like measuring the color of objects. And then I bought the LEDs, and they showed up in this magical Digi-Key box. And let's show them on the overhead, and I'll show off what they look like. So, hold on. Okay, so I got a cut tape of about 10 pieces. And this is the LED, and you can see on the bottom it's got kind of like a large pad connection. And then let me check if I enabled. Oh, I did not enable the LED. So let me try enabling the LED, and then I'll place it and show it lighting up. And then we will be happy because we will have white light. So give me a second. Are there any questions from people?
No, we got to them. As we were getting started, though, people commented on your remarkable ability to only have a few tabs. And before everyone starts dispensing comments, most of the show setup is just closing down tabs.
It's mostly closing tabs. I only have the tabs I need. So let me see, it's the other way. Okay.
Whoa.
So yeah, it's extremely bright, but that's good.
Okay.
So
now what?
Well, I would solder it in, and then I'm going to point it at different colored things and see if
how it goes.
The color reflected back, from a red object or a green object. I mean, I did do this. Hold on, if I
there was a question. With those large pads of the LEDs, are they for heat sink as well?
Yeah, I think that's what. That's sort of why they're so large. I think it's to
focus in on that.
Yeah, sorry. I know this is not.
Yeah, this is overheads really don't like it when you like mess with them like this.
No, they don't like this at all.
What are you gonna do?
Hold on, sorry. I wanted to show placing it so I didn't solder it. But that means
Yeah, that means you have to find.
I have to find it. Hold on. Oh, I don't know. All right. Well, basically, what I'm going to do is later on, I may also damage this, but
Yeah, sure.
solder in the LED and then point it at like red objects. And I've got like pink, and I've got like purple and blue and green, and then see if the color that's reflected off of those matches the color that I see. I'll say that I did try this a little bit at first, and again, because what we perceive as purple, it's not necessarily true purple dye. It's usually red and blue dye mixed together to make a purple that our eyes see. And so when you actually measure the color of a purple object, you usually don't get purple light reflected back. You get a high blue and high red component. What you normally have to look at is non-dyed, like natural objects that are a color. Those are less likely to be mixed colors and more likely to be like the true spectral color that you're expecting. So something to watch out for with spectral sensors. And that's what I got. I got this sensor going. I got some white LEDs. I'm ready for my next steps.
Okay, right on. Well, we're going to continue to be doing this sometimes around 8-ish, the 8.
Well,
Sunday,
we don't
Disco
say
LADYADA.
what time zone.
It's on hacker time on Sundays because the weeks are intense. But one of the things that we do if we have a moment is exactly what we like to do during the week. Share electronics, get together, make stuff, show that there's a big community out there, people who like to build things and come together, and so that's why we like doing Desk of LADYADA. So that's it.
Okay.
We'll see everybody during the week. Don't forget, Tuesday, John Park Show, which is Make Code. Wednesday, we have a bunch of shows. We got 3D Hangouts. We got 3D Hangouts with the Show and Tell. We got a Show and Tell. We got Ask an Engineer. Thursdays, we got JP Show. We have some Show and Tell action with JP. And then on Fridays, we got some deep dives with Scott. There's a lot of stuff going on. Thank you so much, everybody, for helping us and supporting us through all of this. It ain't over, so your orders always help.
Thanks, everybody.
We're going to be doing this for a long time, and we thank you very much in every possible way for keeping us going.
Okay, cool.
Okay, thanks so much,
Good
everybody.
night, everybody.
Bye-bye.